I think a good bit of this number have been here for the whole series, so I have long since learned that when you teach something, and especially something that's new to people, there are 3 rules of teaching. You know this? The first rule is repetition. The second rule is repetition. And the third rule is repetition. So what I should do this morning is give you a summary of what we talked about yesterday. That took an hour and a half. So there will be very little summary, and I apologize for that. There's just not time. I want to lay a brief amount of groundwork, because some of you were not here, and then we want to get into the topic for this hour. Thank you for being here. I should say a number of things by way of introduction. I don't have time, so thank you for being here. Let's go. Let's start with a prayer. Our good Father, we offer thanks to you for a beautiful morning, for the privilege of gathering here at this place in quiet and peace and without interference. And we pray that you will bless our time together, that we will learn things about your magnificent creation that will cause us to be in greater awe of the God we serve. I pray for the ability this morning to magnify the God of heaven. And I offer this prayer in the name of Jesus Christ our Lord. Amen. Is it reasonable to believe in God in this scientific age? My answer is more reasonable than ever in the history of mankind. The exact opposite answer of a lot of folks, particularly in higher education. They would tell you, no, it is not reasonable to believe in God anymore. Get over it. Romans, the first chapter in verse 20, is the passage upon which this series is based, so I like to begin with that, particularly when we're doing this series in a church building. If you had come to a college lecture hall yesterday, we wouldn't be talking about this book at all. We'd only turn to the evidence of the natural world. And we do that because this book, in which I believe firmly is the Word of God, teaches us that you can learn about God independent of this book. Romans 1 verse 20 says, "For since the creation of the world, His invisible attributes are clearly seen." In other words, you can see God even though He's not observable. How do you do that? Being understood by the things that are made, even His eternal power and Godhead, so that they are without excuse. That passage teaches that you can learn about God independent of this book. You see, God has another book. It's the book of the natural world. And it is to that book I want to turn for the rest of our time this morning and this evening. We're not going to look at that book. We're going to look at the other book. So join me, will you, in looking at God's other book. It's the argument from design. Things that are designed demand a designer. We call that designer God. So I started yesterday with a search for extraterrestrial intelligence. I did that for a reason. Scientists are looking out into outer space for evidence of intelligence. I think that's just fine. I believe you can use science to look for evidence of intelligent design. That's what I'm doing in this whole series. And it is not unscientific to argue that evidence from the natural world can testify to a grand designer. Now, I believe you'll have to get off at some point, because science cannot investigate something that's supernatural. But can it point to the existence of such a one? I believe it can. So SETI says, we're an exploratory science that seeks evidence of life in the universe by looking for some signature of its technology. So, ladies and gentlemen, I want to direct you to the signature of God's existence. Not just out there looking for intelligence. And by the way, they're not looking for God, they're looking for some other intelligent civilization. But why not use the same kind of reasoning and look for the existence of God? So that's what we're doing in this series. We're looking for some signature of a designer. What if we received a message from outer space with a language in it that we could decode and read? I will tell you, SETI and every other organization on earth would say that's grand evidence for intelligence. And the interesting thing is we have exactly that in every living cell. And so we referred to this good book, The Signature in the Cell, which I have with me again this morning. I wanted to show you how thick it is. It's a very excellent treatise that came out in 2009. I highly recommend it to you as a source of information if you want to dig more deeply. And we have lots of young people in this audience. Thank you, congregation here, for having such a series where you bring in lots of young people from all over. You're young enough and your mind's pliable enough, you can handle this. So get it. There are signs of intelligent design everywhere we look, specifically in every cell. It includes a language which we've learned to decode and read, and research on DNA continues to reveal signs of design. And so this morning I want to dig a little more deeply from what we've already talked about. You remember, class, that we said the DNA, most of which is located in the nucleus of eukaryotic cells, contains the information. The information has to be transcribed. It has to then be matured. Then it migrates. And then it comes out here outside the nucleus to the ribosomes, where it is translated and builds proteins. Now that's about a 30-second treatment of something that deserves 2 years. We touched on that yesterday. If you weren't here, I'm sorry. Get the tape. Today's lesson is design at the microscopic level, signature in the cell, but what about junk DNA? Raise your hand. Have you ever heard junk DNA? Several people have. Junk DNA is a problem for a creationist because we don't believe God makes junk, do we? In fact, there's a famous old saying, God don't make no junk. So if there is junk DNA, it would make you question, why would a designer make something that has a lot of junk in it? Wouldn't you agree? So it's a problem. So the question, what about junk DNA, is a good question to ask. And I have a reason beyond just that. And I'm going to say it now lest I forget it later. Here's what I want to say to you. There will never be a time in the history of mankind until the Lord comes back again that you have the answers to everything. There will never be a time. In fact, I'll add to that. There will always be things that can challenge your faith in God. Always. That will come up that you don't know how to deal with because you just don't know. And it sure looks like, well, maybe there isn't a God. Maybe there's some other explanation for things. I'm convinced there will always be things like that. And I remind you of Hebrews chapter 11, verse 6. For without faith, it is impossible to be well-pleasing to God. For he who comes to God must believe that he is, and that he is a rewarder of those who diligently seek him. Hebrews 11:6 from that book. What that means, class, is that you will always have to have faith in God. There will never be a time when it can be so absolutely established that there is not faith involved. I think junk DNA is like that. For me personally, I became acquainted with junk DNA much too late. In fact, I was doing a lecture like this at the University of South Florida and talking about the stuff I told you yesterday. And during the Q&A, a professor stood up and said, now, Dr. Payne, you gave some interesting information to this class, and you explained to them the marvelous process by which proteins are constructed inside of living cells. What you didn't tell the class is that most of that DNA to which you so respectfully referred is junk. And why would God make something that's mostly junk? And you didn't bother to tell the class about that. Well, the fact is, class, I didn't know much about that. And here I am giving lectures. Because I will tell you, this is such a fast-changing subject. We're learning more stuff every day. The amount of knowledge that we know about the living cell at the chemical level is so massively increasing every second that just to give a lecture like this is almost embarrassing, because you can't keep up with it all. So I really didn't know exactly what to say. So I kind of bumbled around a little bit and said, well, sir, I need to look into that more in detail and be sure I'm up to date on this. Thank you for helping me. I would tell you this, though, and I'm thankful I was able to think of this. You might ought to be careful about what you call junk. And is there history in science in which some folks made observations like that in the past and ended up being embarrassed? There is. For example, I made some notes on this. Let me get them out here. There was a fellow named Robert Wiedersheim in 1893 who wrote a book called The Structure of Man. He was a German biologist. He listed 86 human organs he considered vestigial. In other words, we were a veritable graveyard of leftovers from our evolutionary past, the human body. 86 vestigial organs. You know what vestigial means? That means leftover and useless. He listed 86. He said, just look at the human body. It's just a bunch of leftover junk from your evolutionary past. Out of those 86, class, how many of them do you think are still considered vestigial? None. Maybe one or two or three, depends on who you talk to. Here are some of the ones he listed: the muscles of the outer ear, the wisdom teeth, the appendix. I'm sure you've all heard of that one. Appendix is supposed to be vestigial. It's leftover from your evolutionary past. You don't need it. Well, you know you can live without it, right? Tailbone. What in the world do you have a tailbone for? It's a leftover from when you were a monkey. Body hair, the pineal gland, the thymus gland, the pituitary gland, the tonsils and the adenoids. How many in this group have had your tonsils and adenoids removed? Raise your hand. I want to see you. Almost no young people. When did you have yours taken out? Okay, well, you're one of the few youngsters. Did you have special problems? Okay. Understand. Listen, when I was your age, in fact, I was living in Holland when I had mine taken out. I was sitting on a nurse's lap and they put gas on me and took my tonsils out. Listen, it was standard procedure to remove your tonsils and adenoids when you were a youngster because you didn't need them. They were vestigial. Nobody believes that anymore. So, Mr. Wiedersheim, and I was able to say this at that point, Mr. Wiedersheim would be embarrassed if he were still alive because he thought the human body was a veritable graveyard of leftovers, junk from the past. So I would be a little careful about calling DNA junk. Maybe we should say respectfully, we don't know what that stuff is doing yet. Okay? I think that's the best answer for that. So what about junk DNA? Well, here's what I want to tell you. And let's just walk our way through this a little bit. By the 1970s, biologists already knew that much of our DNA was not used for making proteins. Now, I've taught for a long time. Half of you missed what I just said. So listen to me and look at me. Everything I told you about yesterday was to show you how your body builds proteins. You said protein out loud about 10 times or 20, didn't you? That's what it was about yesterday. What I'm telling you today is we knew all of that before the 1970s. This is 2018. In the 1970s, it began to become clear that sizable sections of the DNA were not used for building proteins. Did you catch it that time? That was the 70s. In fact, one gentleman named Sunu Ono of the City of Hope National Medical Center in Los Angeles published an article wondering out loud why so much junk DNA is in our genome. That was one of the earliest people to start talking about that. His colleague, David Cummings, from the same organization, said it appears only about 20% of the human genome appears to be used. And about 80% appears to be junk. Okay, the old 80-20 rule. 20% used, 80% not used, it appears. That's in the 70s. In the 80s, things were developing along. We were learning more and more. Here's an article by Leslie Orgel and our famous Francis Crick. You remember him? Co-discoverer of the structure of DNA. They wrote an article entitled Selfish DNA, the Ultimate Parasite in the early 1980s. And quoting out of that article, they said much of the DNA in higher organisms, they do consider us higher. H-I-G-H-E-R, higher. Much of the DNA in higher organisms is a little better than junk. Its accumulation in the course of evolution can be compared to the spread of a not too harmful parasite within its host. Did you catch that? The position they were taking in the 1980s was, it looks like DNA has a bunch of stuff in it that just evolved over time and that's left over as a parasite and it's kind of riding along, not too harmful. So said Orgel and Crick in the 1980s. Side trip. In the 1980s also began to be published some of the best material I've ever seen up to that time from a creationist standpoint. I'm going to give a bibliography to Scott that'll contain all these books. I highly recommend them to you. One of the earliest ones that came out was by Thaxton, Bradley, and Olson. It was called The Mystery of Life's Origins. And those three gentlemen, well-published scientists, questioned every theory that had been proposed to that point about how life started. They showed what was wrong with them. And at the end, they proposed maybe life was designed. And there was a firestorm of reactions against that. It's almost like they committed heresy. May I say a comment on that? I have watched in my lifetime as the scientific community has behaved in ways much like the Roman Catholic Church during the Dark Ages, where they marked people as heretics for questioning anything the church said. Hit OK. Just enter. Thank you. Why does it do that, Sam? I don't like it. Where was I? The Mystery of Life's Origins. Thaxton, Bradley, and Olson. You ought to read that book. Came out in the 80s. It's a little dated now, but it shows you why every of the theories about how life originated, I'm telling you, they're fairy tales. They questioned it. I'm proud of them. And believe me, they had a firestorm of reaction. Another great book published that century, or that decade, was by Michael Denton, Evolution, A Theory in Crisis. Michael Denton. If you're a student of this, you need to read that book. A third one that came out was by Philip Johnson called Darwin on Trial. He's a Harvard lawyer that was questioning Darwinism from a legal standpoint. If you looked at the evidence, could you convince a jury? And he said, absolutely not. Darwin on Trial was a good one. Well, you can imagine, because that was starting to happen by respected scientists and other educators, the other side began to react even more strongly to put down these guys who were claiming intelligent design had some scientific respectability. We're not going to have it. So coming out in the 1990s were statements like this one from Ken Miller of Brown University. He defended Darwinism Darwinian evolution against the idea that living things were intelligently designed. And here's a quote from Ken Miller, highly respected biologist who is responsible for many of the high school textbooks in biology, or was. The human genome is littered with pseudogenes, gene fragments, orphan genes, junk DNA, and so many repeated copies of pointless DNA sequences, it cannot be attributed to anything that resembles intelligent design. If the DNA of a human being or any other organism resembled a carefully constructed computer program with neatly arranged and logically structured modules, each written to fulfill a specific function, the evidence of design would be overwhelming. In fact, the genome resembles nothing so much as a hodgepodge of borrowed, copied, mutated, and discarded sequences and commands that has been cobbled together by millions of years of trial and error against the relentless tests of survival. It works, and it works brilliantly, not because of intelligent design, but because of the great blind power of natural selection to innovate, to test, and to discard what fails in favor of what succeeds. Now I know I lost you. The bottom line of that was he was saying, DNA is no testimony of intelligent design. It's the biggest bunch of mess you ever saw, and it does not look like anybody designed it. It looks like it's a leftover of a bunch of trials and tests with a bunch of junk in it. And a few things work, thank you. That's what was coming out in the 90s and early 2000s. About that same time, it was decided, let's see, why did I put that back in there? Let's just go on to this. It was decided that it is important for mankind to map the entire human genome. And so arose the Human Genome Project, conducted by Francis Collins. Dr. Francis Collins, with a host of folks from all over the world. One of the largest projects of scientific research ever done in the history of mankind. And you know why that is. It started in the early 1990s with the goal of cataloging the entire sequence of nucleotides in the human DNA. Anybody want to venture a guess of how many nucleotides roughly there are in the human DNA? 2 billion? Close. It's 3 billion. You were only off by 1 billion, and in governmental things, that's nothing. Right? For government work, that's plenty close enough. Yeah, just what's another billion? There are over 3 billion nucleotides in the human genome, so they wanted to map the entire thing. You have no clue, class, how massively difficult that is. They started in 1990. The project finished in 2003. 13 years of work by labs all over this world. Massive. This mere catalog, and by the way, you can go look it up online. You can read every nucleotide in the human genome. If you ever have trouble going to sleep, get that out and start reading it. It's much like, let me see if I can illustrate this. If you had a video, a tape, Sam could speak to this better than I can. Here's a videotape that's got a movie on it. And you could show on that tape every magnetic strip of it and what's happening magnetically inside that tape and make a list of them all. That's what it is. You couldn't see the movie. I mean, that wouldn't help you see the movie, would it? If you knew every little piece of on that magnetic strip. It's kind of what this is like. They have now mapped out the entire human genome, but please, that doesn't tell us how that all works. So what happened following the Human Genome Project is other projects started, like ENCODE, which is short for Encyclopedia of DNA Elements, and FANTOM, F-A-N-T-O-M, which stands for Functional Annotation of the Mammalian Genome. We'll have a test on that later. Those two great projects started. to help map out what are the different parts of the DNA genome doing. And so they tried to start that, and that's massive again. And if we didn't have computers to map all this and to help us with this, there never would have happened. So those things were taking place in the 90s and the early 2000s. And as we uncovered more and more, I'm trying to paint this picture for you as vividly as I know how. So I'm going to quote from some of the most ardent anti-creationists. So here's Michael Shermer in 2006 in Skeptic magazine. We have to wonder why the intelligent designer added to our genome junk DNA. Repeated copies of useless DNA, orphan genes, gene fragments, random repeats, and pseudogenes, none of which are involved directly in the making of a human being. In fact, if of the entire human genome, it appears that only a tiny percent is actively involved in useful protein production. Rather than being intelligently designed, the human genome looks more and more like a mosaic of mutations, fragment copies, borrowed sequences, and discarded strings of DNA that were jerry-built over millions of years of evolution. Now, you may say, that's enough of those quotes. No, I want to give you two more. Because there were lots of them taking place in the 90s and the 2000s, even up until this day, about this subject. So please understand, I'm not going to be exhaustive in this, but I have to quote Richard Dawkins, your favorite anti-Christian, anti-God person, and with a hateful personality. He's just mean, that's all. And I wouldn't mind telling him that to his face. You're just mean, sir. Why don't you be nice about it? I'll try not to be as mean to you as you are to everybody else. So in his 2009 book, The Greatest Show on Earth, The Evidence for Evolution, he made the following comment. It is a remarkable fact that the greater part, 95% in the case of humans, of the genome might as well not be there, for all the difference it makes. In particular, pseudogenes are genes that once did something useful, but have now been sidelined and are never transcribed or translated. Dawkins concluded, what are pseudogenes useful for but embarrassing creationists? It stretches even their creative ingenuity to make up a convincing reason why an intelligent designer should have created a pseudogene. You know what the word pseudo means? Fake. We hear fake news all the time now, right? He's saying we got a bunch of fake genes in our genome. Why would God put a bunch of fake genes in there? Unless he was deliberately setting out to fool us, says Dawkins. So lots of statements like that were going out. I have an appendix to this little book, which I'll refer in just a moment. And in this appendix, there's a whole section here on the vitamin C pseudogene. So let me just take a brief moment and explain that to you. In the human genome, there's a section of our genome that looks like it's a gene to produce vitamin C. Did you know your body doesn't produce vitamin C? Do you need vitamin C to live? Yes, so you better be taking it because your body doesn't make it. So I take, every time Marilyn sees me, she gives me 2 more vitamin C's. 2,000, whatever they are. But you need vitamin C, so you have to take it because your body doesn't make it. Here's the argument. This section of the DNA in our body appears to be parallel to one in a mouse and other less advanced creatures who do produce vitamin C. Did you know there are lesser creatures that do produce vitamin C? And we don't. And yet that section of our DNA appears to be comparable to the one in theirs. Theirs works, ours doesn't. So why is that? Well, of course, an evolutionist would argue, over time as we evolved into higher creatures, there were mutations in our DNA that knocked out some of the stuff, and our pseudogene doesn't work anymore. Theirs does, ours doesn't, perfectly explained by evolutionary process. So the vitamin C pseudogene has been a big deal. Why, you believers in God, would God leave the leftovers of a pseudogene for vitamin C in your DNA? Makes no sense. So, that's why Francis Collins, in his book, The Language of God, the director of the human genome, in whole sections of this book argues that what we've learned about the human genome is powerful evidence for evolution. Not against it, but for it. Collins believes that your physical person evolved by natural causes, but he's still a believer in God. And he calls DNA the language of God, but he uses it to support evolution. What he believes is that God placed into you, when you became of the level of humans, the things that are godlike. Are you with me? So the language of God is a powerful evidence for God, but it's mostly the things like your moral sense, your ethical values, your interest in aesthetic things, the ability to think, those things that he believes God must have placed in us. Well, listen, pure evolutionists rake him over the coals for that. They say, we have natural explanations for all that stuff too. You're just not ready to take them. What time do we have to stop?
20 after.
20 after. I'm pausing on purpose, folks, for just a minute. Because I want to let sink in what I just said to you. And I will tell you that I, as a believer in God, was shaken by this stuff. I didn't know how to answer it. And I think we've got to be honest. I'll tell you the worst thing you can do as a believer in God is to make foolish statements you can't support. That hurts the cause of belief in God more than not saying anything. So may I recommend, if you don't know what you're talking about, it's better to say nothing. And I want to add to that. If I in any way misrepresent something about the case for either side of this argument, I want you to correct me, because I don't want to do that. I want to be fair. And by the way, I want to be nice. I mean, I don't mind shouting sometimes, but I don't want to be mean to anybody. Neither should you if you're a believer in God. Be respectful in your dealings with other people. So what do you do with all this? Here's what I'll tell you. Give it about 20 years. And answers will start coming that you didn't know anything about. But believe this. There is sufficient evidence in the natural world that God has already provided, and He's provided in every generation. Lots of people, do you think Abraham knew about junk DNA? Well, I'll tell you what Abraham knew enough about. He knew he was too old and his wife to have babies. Right? They knew enough biology to know they were past the age of childbearing. God said, you're going to have a son. And he believed it anyway. Right? And he acted on his faith. There are going to be situations just like that in every generation. You'll never get away from it. Because he that comes to God must believe that he is. That means you do not absolutely know it with all certainty. No questions. There'll never be a time like that. But faith is the substance of things hoped for, the evidence of things what? Not seen. It's what fills in the gaps of things you can't observe. Everybody does it, not just believers in God. And evolutionists that I've talked to hate that. They don't want the word faith in there. I had one guy in one of these lectures up at the University of Maine said to me, "There's no faith in our system. We base it on facts." I said, "Sir, do you really believe that?" You get what I just said? And later in the course of that discussion, he ended up saying something like, "Well, Professor Payne, I believe," and he caught himself. I said, "Thank you, sir," because that's the fact of the matter. You somewhere have to get off and say, "I believe that." Now, can it be based on evidence? Absolutely. But everybody has to get off at some point and say, "I believe that," as the best explanation for this evidence. I didn't observe it. Nobody has observed the general theory of evolution, class. Nobody. That is a conclusion based on what they call massive evidence. I say the massive evidence can be interpreted in a much more reasonable fashion. And by the way, I get tired of hearing them say, "All you folks do is criticize us and our evidence. Why don't you bring your own evidence?" And the answer is, the evidence is the same. We all look at the same evidence. What's different is the interpretation of that evidence. So what do you do with junk DNA? Many began to say only about 5% of the DNA is used in protein building. You know what the latest is? It's more like 1.5% of the DNA is used for building proteins. Well, what about the rest of it? As I've already read you, many people were saying it's junk. And why would anybody believe in a designer that made something 95% junk? So what do you do with that? Well, you cry a lot. I'm kidding. I mean, you try to come up with something. My best answer is, let's wait and see what that junk is doing. And I have been gloriously supported. Because in the last 10 to 15 years, ladies and gentlemen, we've learned a whole lot about junk DNA. And if you don't get anything else from the rest of this lecture, I have 10 minutes to cover a subject so massive. If you don't get anything else from this, get this. In the last 10 to 15 years, we've uncovered so many things that junk DNA is doing that anybody who calls it junk ought to be ashamed of himself. So I'm going to show you a few things. And I'm going to recommend this little book by Jonathan Wells, The Myth of Junk DNA. He calls it the last great icon of evolution. The last great myth for our time. A myth means it ain't so. That book is full of lots of references which you can track down and follow for yourself. Don't you believe what I'm saying? You go track it for yourself. I'm going to quote for you things that evolutionists have discovered. Evidence suggests that DNA is probably functional, even in its non-protein coding sections, which may be as much as 98% of it. Most non-protein coding DNA is coded into various RNAs. Now, if you were with me yesterday, you know that RNA makes copies of the DNA, right? There's lots of RNAs. What we've learned in the last 10 to 15 to 20 years is there are a massive number of RNAs of all kinds. And that even those that are not coding for proteins are doing stuff. And most of the DNA is being copied, not just the protein coding sections. Are you with me? If it's being copied, there's probably a reason for that. Do we know all the reasons? No, we don't. But we do know that most of the DNA is being copied into RNAs. And many non-protein coding DNA sequences are conserved. Now that's a tough thing to explain to you in a minute. So I'll just say this. A mouse and a human has lots of non-protein coding DNA that are almost identical. For an evolutionist, that means over millions of years that's been conserved, because a mouse evolved a long time before we did, they would say. And yet our DNA is very similar. Well, what that means is it must have some purpose. To them, even an evolutionist would say that. I lost you, I know, but let's go on. Evidence for specific biological functions of non-protein coding DNA. Not only do we know it's being copied, but we know there's some specific things those RNAs do. RNAs from this DNA play a significant role in controlling whether, where, and to what extent protein coding regions are transcribed. So the regions that do transcribe the proteins are being guided by the non-protein guided guys. Here's the best way I can say that. What we're beginning to learn, class, is that the rest of that DNA clearly is in the process, or is in the business of managing all the other stuff going on. You know, young people especially, some of you older may know this too, if you were trying to use a computer, you have to have a what to make it work? An operating system. You have no operating system, the thing doesn't work. Or if the operating system breaks down. You have to have an operating system. It appears, class, that the rest of that DNA is being used in various amazing ways as an operating system for the whole process of what's going on in the cell. That's part of what we're learning. So is it junk? Be careful. You may be embarrassed. Now, you remember when I talked to you yesterday, I said in the protein coding part, when the copy is made up here of the DNA, here's the copy. See those white areas in there? 10 minutes? Okay. Those are called introns. That's an abbreviation for something. I can't remember what it is. But there's sections in there, the little white sections, are not used for making proteins. In fact, what happens is the cell snips those out and reconnects the other pieces into a mature RNA, which then goes out and makes the protein. So the question was, what are these in there for? You remember I told you that introns at first were thought to be junk? They're just sections in there that have no purpose. And why would a designer make something where you have to throw away part of it before you use it? Why would he do that? Good question. Well, I will tell you what we're learning. Introns have lots of functions. Those little sections that are snipped out. First of all, by the way, how in the world does our body splice those things, cuts them out and reconnects them? Is that amazing? I'm going to ask you a question. What do you think it takes to splice and reconnect? Thank you. Those of you who weren't yesterday, and the answer to every question was proteins. There are special proteins called spliceosomes and editosomes that do all that work. Amazing. Introns have a function. We just didn't know it. In fact, there are lots of functions. Introns are rich in splicing factor recognition sites. That means they're important for where and when and how to splice. They encode a majority of the small RNAs, which do all kinds of stuff. Small RNAs come from introns, class. And we know already a lot of those RNAs from introns do all kinds of stuff other than build proteins. RNAs from introns influence gene expression by modifying chromatin, another whole subject. I wanted to get to this. How much time? This is absolutely incredible. What we have learned in the last 10 to 15 years, folks, is there's more information concentrated in DNA than we ever dreamed. Because every single section, let me go back now, right here. This thing here, that one piece, can be spliced and edited into sometimes up to 1,000 different proteins. You listening? The same section. Because what if you cut out this piece, and this piece, and you hook those two together, and then you make this one again and put it over here, and you make 1, 1, 3, 2, 6. That's one protein. What if you did 2 of these, 1 of these, 2 of these, and 1 of those? While you're splicing and editing. You see? From the same section of information, you can build up to 1,000 different proteins by editing and splicing and reshaping. So what we're learning is the concentration of information in the DNA is more massive than we ever dreamed. All organized and working fine, thank you very much. Thanks to the non-protein coding sections. I have to use this example. This is from this book, Signature in the Cell, 5 minutes. Yeah. There are, in some cases, ladies and gentlemen, multiple messages stored in the same section of information. Multiple messages! You listening to me? To get a picture of how this works, imagine a coded message in a letter sent back across enemy lines during the Revolutionary War. Read it in the standard way, and the letter describes problems on the farm, the weather, household challenges, and progress the children are making in their studies. All of it clear and accurate information. You read it one way, you're reading about family. But if you know the code, your letter also managed to encode another message about enemy troop strength, movements, supplies of ammunition, and an impending enemy attack in the same letter. It's coded in there. A message inside the message, but you can only read it if you know how to read it inside the letter. Now, do you think humans can do that? We do it all the time. And it was done in the Revolutionary War. That's a real story. So the soldier receiving that had learned from his wife and the one helping her how to get messages from her inside a letter about family. Okay? Does that require intelligence? Do you think there's any way on God's earth natural selection acting on random variation could produce messages inside of messages? But that's precisely what we have in the DNA. Numerous instances of messages inside of messages. So there's more information than we ever dreamed in there. And we're just beginning to uncover it. Codes within codes, dual and overlapping messages. Pseudogenes. What about that pseudogene for vitamin C? I'll tell you what we're learning. Some pseudogenes have produced functional proteins. They're not just sitting there. Some produce RNAs that suppress the expression of their corresponding functional genes, and some produce RNAs that increase the expression of the corresponding functional gene. There's stuff going on with those pseudogenes, which they just like to make fun of as leftover from the evolutionary past. We know they're doing some stuff. Now, have we solved it all? Not at all. There's still a bunch of stuff we have no clue about. But do we have some hints that pseudogenes may not be so pseudo after all? Yes, we do. And you can read Francis Collins about that because some of his own research have shown it. Repetitive and non-protein coding DNA. There are lines and signs and endogenous retroviruses. Sorry, Stephen, I'm not going to get to endogenous retroviruses. How do you like that word? Did you know there's some information in DNA that was inserted there by viruses? You know why viruses are so dangerous to us? They get inside your body and they can infect your DNA and insert their DNA into the DNA you have. And then it starts making copies of that and kills you. Retrovirus means they put their information inside your DNA. You know what I think about that? That's one of the consequences of sin. Of course, I'm not going to say that in a science classroom. But we got all kinds of mess happening because this world has fallen and we deteriorate. But evolutionists love to pick on endogenous retroviruses, another evidence of evolution. I say it's an evidence of decay. And how does that help evolution? And then files within folders.
Right.
There's a lot of storage going on. Amazing. You ever look at your desk at home? Imagine trying to organize DNA. And it's organized. It's incredible how it works. You don't lose anything? Well, you do sometimes. It's amazing. The more we learn about supposed junk DNA, the more it appears to be designed. Or as Michael Behe would say, everywhere we look, from the macroscopic to the microscopic, things look like they're made. It's a loud, clear, piercing cry of design. And by the way, in his book, he writes it in capital letters with 3 exclamation points, so it's okay for me to yell. And it is a fact, ladies and gentlemen. Junk DNA is beginning to give a grander testimony to design. But there's still a lot to learn. And that's my talk. Not too bad. It's 22 after. So we take a little break here. Is that what we want to do? All right. Thank you, everybody. You were a good attendant class.